Welcome to Fascinate. My name is Kate and I'm a Brownie leader and work at RAL Space at the Science Technology Facilities Council, STFC, where I'm an environmental data scientist. Today, I'm also joined by Vicky, who's a science communicator, Louise, who's a project manager, and Catherine, who's a thermal engineer. I'm going to now pass over to Vicky so she can do a quick introduction to what RAL Space is.
Thank you, Kate, and hello everyone. Really excited to be here today. So as Kate mentioned, we work for RAL Space and we are the UK's National Space Laboratory. That sounds very exciting, but what does that actually mean? So we helped build and test spacecraft, and we've been involved in over 210 instruments that are on board spacecraft over the last 50 years, and we've got lots more to come in the future. And one that we'll be launching later this year is called the Webb Telescope. So today we're going to be making a model of the Webb Telescope. So before I get into that, I'm going to talk a little bit about what we do at RAL Space. So as I said, we are involved in lots of different types of missions. So we can be involved in satellites that are in orbit around Earth, that look down on Earth. So these are Earth observation satellites, and that can help us look at the weather or look at climate change. We're also involved in spacecraft that look out towards the sun to find out how the sun works. And then also astronomy missions looking out deep into space, into galaxies and stars and planets, and also putting things on Mars, so looking at exploring the solar system, lots of different things that we do. And we're involved in lots of different stages of a space mission as well. So from the very start, thinking of new ideas for space missions. If scientists have questions about Earth or about another planet or about how galaxies form, they have these questions and we need to design a space mission to investigate that. So the next part is designing the actual spacecraft. So what parts do we need in order to find the answers to those questions? Do we need a camera? What type of camera do we need? So we're involved in that design work. And then we have to test it. So before it goes into space, we need to make sure that everything works as expected and that it will work in the conditions of space. Because once it's in space, it's quite difficult to fix something if there's any damage. And it's also very expensive. So we try to make sure we get it right on the ground first. So testing is very important. And then once the spacecraft is in space and sending back data to us, which could be images, we store all of that data. So we have a big supercomputer called Jasmine, and Jasmine has very, very big storage, much bigger than our laptops, and works very quickly as well, so that scientists across the world can access the data to do their own research as well. So lots of different things that we're involved in. And we have about 300 people working for us at the moment. We're based in Oxfordshire in England. And we also have opportunities for school students to do work experience with us. We have apprenticeships, and we also have university students who work with us whilst they're at university or just after they've finished university as well. So that's a little bit about what we do, lots of different things. And today we are going to have a go at making models of the Webb Telescope. So I'll talk a little bit about what the Webb Telescope is. The Webb is short for James Webb Space Telescope, and it's going to be the successor to the Hubble Space Telescope, which you might have heard of. And Hubble has been the telescope that's taken lots of amazing images of galaxies and stars, really, really interesting things. And it looks in visible light, so the same wavelengths of light that we can see with our own eyes. But the visible light, we can't see through dust. So there's some dust in galaxies and around where stars and planets form, and we can't see through that with the visible light. Webb will look at infrared wavelengths of light, and this will help us to see through the dust and see more detail, and it will help us to find out things like how galaxies form. So do bigger galaxies form from smaller galaxies? Do they merge and combine to make bigger galaxies? How does that happen? We'll also look at how stars are born. So what is the life cycle of a star? And lots of other really interesting questions as well. And Webb is it's going to be one of the biggest telescopes as well that's going to go into space. So I think the primary mirror, which is the big mirror that's going to collect all the light, that's going to be about the size of a tennis court, I think, to give you an idea of the scale. It's also going to be one of the heaviest spacecraft we've ever made and one of the most expensive, so biggest in all different scales and dimensions. So there's lots of engineering challenges involved in that as well. And lots of our engineers have been working on parts of that for the last few years. So I think we're going to go and get started, and let's actually have a look at a picture of the Webb Telescope to see what it is that we're going to be making today. So as we can see, we've got a big gold primary mirror, and it's the shape of a hexagon, and it's made of lots of smaller hexagons. So this is what we're going to be making first of all today. We're going to be doing an origami activity to make a hexagon, and you can make this on your own. You can make your own hexagon, and if you're able to meet with other people, or if you want to make more hexagons, they tessellate, so they all fit together, and you can make one big primary mirror that's the same as the one that will be on Webb. We've then got these sun shields at the bottom as well, and we'll do a bigger model in our second activity today to have a go at making that. So that's our aim today, to try and make one of these. And I'm now going to go through the origami activity. So I'm very grateful that I've got lots of helpers with me today to have a go at this. Don't worry if it goes wrong. It's all about trial and error and improving how we do things. So first thing we are going to do is take a big piece of A4 paper, just a piece of plain A4 paper. I think everyone's got. And I'm going to change my view so you can see the desk. So what I'm going to do. I think, Kate, you're recycling a bit of paper, aren't you?
Yes, I have a recycled scrap piece of paper.
There we go. Right. So the very first thing we do, nice and easy, we're just going to fold our piece of paper in half lengthways.
It might be easier if you have a table to do this on as well.
There we go. And then we're going to take one of the flaps and we're going to fold it back the other way. So we're going to fold it again in half, fold it back the other way. And the same on the other side. So I'm going to then turn my lamp off so you can see the paper a bit better. There we go.
So it's almost like the steps of when you make a paper aeroplane, but not quite.
I've done that. So if I show you where I'm at now, it'll look a bit like this. You'll have kind of two ridges like that. Excellent. Right. Going well so far. So now let's turn our piece of paper over so that it's a W shape. So we've got our W shape. We're going to fold in the left panel. So that's going to stay folded in.
So it looks like an N shape?
Yes, now it's an N shape. There we go. Now we're going to take that bottom left corner and fold it up to the middle, and the fold is going to start from the little ridge at the bottom there. So the fold will start from there, and we want to get our bottom corner into the middle.
Okay, cool.
So mine looks like that. There we go. So the corner goes into where we've got a crease there, and the fold starts from this crease.
Okay, yep, I got it. There we go.
Cool. Great. Okay, now I'm going to remind myself of what the next fold is. Yes, so as we've already got a little crease here that's kind of just on this little triangle. Yeah, it's a bit small to see, but there is already an existing crease now there, and we're going to use that as our folding line for the next bit. So this corner is going to be folded up, and we're going to use the small crease that's already kind of existing to fold it up, if that makes sense. Oops.
So just folding exactly along that crease rather than a different angle.
Yeah. So what we'll end up with is what looks like two triangles. Yeah. Yeah. Yeah, I think that looks okay, Kate. Yeah.
Yeah.
Cool. Right. Now this is an easy one. We just fold in this big long panel that we made at the start. We're going to fold that one in back into the middle and fold that down. So we've now got what looks like a rectangle with two sort of triangles at the bottom. Okie dokie. Now, this next bit, where we've got our line on the left-hand side, where we've got our triangle length, that's going to be our next fold line. So we're going to fold the whole bottom section up. And it's going to be along that top line. So what you'll end up with is what looks like the top half of a hexagon.
Ah, it does. Excellent.
Yeah, good. So we've got that top of the hexagon. And then fold that bit out again. So we've made a nice big crease line. Okay, now we're going to fold the top half down, and it's going to be so that the right hand edge goes down that crease line that we've just made. So again, we'll end up with half of a hexagon. So the right hand edge goes down along. So we end up with half a hexagon. Yeah. Yep. Kate, what does yours look like? Have you got a half a hexagon?
Oh no.
No, I think I've gone badly wrong.
Do we
It
want to
started so
rewind a
well.
couple of steps?
Yes, let's go back a few steps.
Okay.
I think I got to this stage. I don't think I accurately folded it in the beginning.
Ah,
Design
Okay.
fold.
so you've got your two triangles at the bottom
Yes.
that are sort of, yeah, they're sort of
So
equal
improve
and opposite.
I'm going to improve my triangles.
Louise, yours looks good.
I've found the next step.
Oh.
Yes. Yeah, that looks a bit better, Kate. So then from there, what we did was we used the triangle line there as the fold line. So we used that and folded it up to make half a hexagon. Oh, almost. That looks a bit better. Yeah.
I mean, it looks better than what it was before.
There we go. We've made an improvement. That's okay. So we folded that up and we fold that back out again so that we've got a big crease line that sort of makes half the hexagon. And then we use that crease line as our guideline for the next one so that we take our right hand edge of our long bit of paper at the top and fold that down across to go along that crease line. So it sort of separates and we've got half a hexagon.
I've got
Yeah.
that.
Cool. Excellent. And yes, the next step then is that we've got a crease line here. We've got two sort of panels here, and we are going to fold the top one down over the bottom. Good. There we go. And then we're almost there now. You can sort of see we've got most of our hexagon. We've just got this flap to sort out. So we are just going to fold that flap down in line with the top of the hexagon. So you can sort of see on the back where the top of the hexagon is. We'll just fold the top bit of paper down to be in line with that top edge.
Oh, it's a hexagon.
Yeah, so we've got a hexagon. We've still got this tiny little bit left. So all we're going to do is tuck that in. So this is the fiddliest bit, I think, but you can sort of open a flap and tuck it in like that. And shimmy it in a bit. There we go. There we go. And we've got a nice hexagon. Hey, we've got a hexagon. That's gone quite well, actually. Well done, everyone.
So we can
There
make
we go.
lots of these to put them together.
Yes, so we can tessellate these to make a big primary mirror, like on the Webb Telescope. And that's our first model done. So well done, everyone. You can save these and put them all together. I'm just going to tidy mine up a bit. You can decorate them if you want. So if you want to have some gold colouring to make it the same colour as the Webb Telescope, you can do. Or if you want to make your own design, feel free to do so. ESA are running a competition on social media. So if you want to take a photo of what you've made, you can use the hashtag #WebAtHome. And there is a competition and they're giving away some prizes. And that's running for most of this year before the Webb Telescope is hopefully launched towards the end of the year. So there's a competition you can get involved in once you've made your hexagons. Great. So well done, everyone, for following along. And what we're going to do now is we are going to ask some questions to our people who work at RAL Space. So I think the first question really, first of all, is what do you actually do? So first of all, Louise, what do you do in your job role?
So my job is a project manager. So this means that I get responsibility for a project, for example, making an instrument or making some electronics to control an instrument. And it's my job to make sure that we complete everything on time and in budget. So I have to communicate with all different engineering teams to make sure that, for example, our design process happens, is successful, doesn't take too long, and then move through into manufacturing. So making the parts that go together and make sure that we assemble everything together and then test it, make sure that it works, and we then deliver it to our customer, whoever that may be, on time. So I spend a lot of time in meetings, talking with lots of groups of engineers, and also looking at the finances and the scheduling and that kind of thing.
Cool. So what would you say is your favourite part of your job?
I think my favourite part is the kind of range of things I get to see. So I can be on projects, for example, that are in the really nitty-gritty design stage at the beginning, where we're mainly kind of figuring out how to make something work, all the way up to kind of managing the testing campaign. So making sure that our instrument is going to survive the launch to space and living in space, and then all the way through to hopefully sometime in the future, something I've worked on will actually launch, but it does take quite a long time to get from that design stage to in a rocket.
Did you always know you wanted to work in STEM?
I think from when I was quite little, I was really interested in kind of how things worked. And I spent a lot of time in the garden playing with film canisters and vinegar and bicarbonate of soda, making them explode like rockets. And then as I went through school, I really enjoyed kind of maths and physics. I also enjoyed kind of writing things and communicating with people. So I decided I was going to study physics, but I learned that a big part of science and of engineering is kind of communicating what you kind of want and communicating with the public to let them know the exciting things that are happening. In the course of kind of my studies, I've learned that STEM actually has a lot of creativity in it. It's not just kind of the studying a lot of maths and the kind of science you do at school. As you grow in your career, it's a lot more creative because you're solving problems that no one solved before.
That's fascinating. So now over to you, Catherine. What's your job role?
I'm a thermal engineer at RAL Space, so my job is designing things to ensure they can survive the harsh temperatures of space, whether that's really, really hot when it's either going towards the sun or facing the sun, or really cold when it's facing into deep space. And even the fanciest things on spacecraft, like spacecraft electronics, can only survive fairly close to room temperature. So we need to make sure that we design the instrument such that it can survive those really harsh temperatures of space. An important part of that, once we've designed the instrument, is also testing it. So we've already said that we have to make sure that something will survive once it gets into space. When we've spent so much money on it, we can't go up there and fix it. So we need to make sure it works first time. So we do thermal testing in a vacuum chamber where we suck all the air out to represent space, and then we heat it up and cool it down to the temperatures that we'll see in space and make sure that it still works perfectly at the end of it.
That sounds really fascinating. So how big are the chambers?
So we have all sorts of sizes of vacuum chambers, right from the very small ones that we use to test little components, right up to really big vacuum chambers. like a 3-meter one that I'm using at the moment, 5-meter ones, and our new one's going to be 7 meters in diameter. So it's huge and it can take an entire spacecraft.
That's brilliant. That's really cool. So what would you say is the favorite part of your job? Do you get to travel normally?
Yeah, travel is definitely one of my favorite parts of the job. So often for test campaigns, particularly when we're checking our instrument is working when it's attached to the spacecraft, we have to travel. So once I got to go to Germany to a customer's test facilities, and there we had to work with all the different instrument teams from all over the world to try and make sure that all of the different instruments that are attached to the spacecraft were all working. So it was a big collaboration with people from all over the world to make sure that the spacecraft that gets launched at the end of the day is the best one that we can do.
That's amazing, and really important that there's so much collaboration and teamwork really across so many different organizations and lots of different people from different backgrounds as well that bring different skill sets and perspectives. That's really interesting. Cool. So I think we should start on our next activity and carry on chatting about what we do. So the next activity is to make a whole model of the spacecraft. So we've just done our primary mirror, which was a hexagon. I actually found I'd also done a hexagon in an earlier session. So I have got 2 that I can tessellate. There we go.
And why is the mirror made of hexagons?
Oh, very good question.
Is it to help it fold?
So I think the way that we're going to launch Webb into space is actually folded up in a rocket. And then once it's launched into space, it can then fold out. So I think that's why we've got these sort of fancy engineering ideas, these new innovative ideas as a way to launch it in space. Because it's so big, you can't just launch it as it is. So we're going to have it folded up and then fold out. So I am going to now do a model of the James Webb Space Telescope, and I'm going to do an edible model because I like food. So I'm going to use some crackers, some Oreos, and some strawberry laces. But you can use anything you've got at home. You can also use, doesn't have to be edible, you could use some household materials. So I think Kate's got some of the materials as well that she's going to use.
Yeah, so I'm going to use an egg box, some lollipop sticks, and I've got some tin foil here as well. I'm going to use and some sellotape.
Good. So I'm just going to go and pop and get some of my materials.
So I have a question. What does a typical day look like for you? Let's start with Catherine.
Oh, at the moment, I have hardware that's being built and tested. So a day for me at the moment is quite exciting. I spend all of my time in a clean room where I have to get dressed up in a suit, covered from head to toe with only my eyes showing so that I don't put any dust into the clean room. And then in there, I'm putting things together. I'm making sure that they're ready to go into thermal testing and all sorts of different exciting things that are building towards finally finishing and being able to hand it on to our customers.
Yeah, it's very important actually that we wear the clean suits and we use clean rooms to make spacecraft, I think, because if you imagine if we have a camera on a telescope, for example, if dust or something got onto that camera when it's in space, we couldn't really wipe it off easily and it would spoil the images. It's very important that we filter the air and we have a very clean environment. Here's me in a clean room suit. You can see we've got a hood, we've got a face mask, we've got the suit, we've got gloves, and we've got big boots that go over our shoes. And that's so that we don't bring anything into the rooms whilst we're building the spacecraft. No skin cells, no hair can fall off us. So that's what we look like. And we have special clean room changing areas that are divided in 2. So there's a dirty side and a clean side. So you get dressed up in the suit and then you can cross over into the clean side, over the barrier into the clean side. So that's what one of the clean room suits looks like. Now let's have a go at building some models of Webb. So Kate, what are you going to do?
I'm going to first of all take my egg box, and this is going to be my sun shield at the bottom. And then I found a cocktail stick, so I'm going to attach this into my egg box so that I can start to attach a mirror on. And I think I'm going to use my tinfoil as my mirror. So I'm going to use some sellotape, which is going to get quite noisy, to be able to attach it to. So I'm going to just mute myself while I attach some sellotape to my model, and Vicky can start off with the edible one.
So I'll show you what I'm going to do. Louise, are you doing an edible model as well?
Yep, I've also got Oreos and crackers
Oh,
ready.
exciting. So what I'm going to do is I'm going to start off with one Oreo on the bottom. This is our little base. And I think this is our control hub. This is the spacecraft bus. So RAL Space has been involved particularly in one instrument called MIRI. And MIRI is going to be looking at the mid-infrared wavelengths, which is very exciting. And we've been involved in the thermal engineering on MIRI. And MIRI is going to have a camera and a spectrograph so that we can take some really cool images of galaxies, maybe some asteroids as well. The next thing is I'm going to add 2 crackers and I'm going to put them like this over the top of each other so that they make these layers of the sun shield that will unfold once it's in space. So you can see that it's on top of my little spacecraft bus at the bottom, and then our solar our sun shield. You can add more layers onto this if you want. You could add some jam or Nutella or anything if you want to really stick it down, but I'm just going to balance it on. After that, I'm then going to take another Oreo and I'm going to put it in half. This is probably the best bit, isn't it? And I'm then going to put the half that's got the sticky middle bit, that's going to go in the middle on top. And I'm going to get a third Oreo and open that up as well. And again, take the sticky half, and I'm then going to put this and stick it upright if I can. So this is what I'm going to have for my primary mirror. It's circular shape, not hexagon. If you wanted to make it a hexagon, you could nibble bits off. But for simplicity today, I'm just going to stick it up. Louise has got hers stuck up there, which looks really good.
And this is what mine's like at the moment. So my primary mirror, I've used my tinfoil as and stuck it to my box.
It's looking pretty good. So the last bit I've got is I've got some strawberry laces for the struts, and I'm quite long. I'm going to put these in half. There we go. And there are 3 struts. Oops. Can sort of balance one on top, one on the edge, and one on each edge. If I had cocktail sticks like Kate, I could use some cocktail sticks and stick them into the Oreo.
Lollipop sticks, and I'm going to sellotape them together and then stick them on.
And then mine, I don't think mine will stay up, but there we go. So I'll have my 3 struts there. And then what I could do is for my secondary mirror, which goes on the end of the struts, I'm going to cut one of the, or split one of the other bits of Oreo into a quarter, make a really small bit. So I've got a little quarter there, and that's my little secondary mirror. And that goes on the end of the struts. Again, if I had some cocktail sticks, I could stick them all together. And then I can hold them up. Oops. It's a bit fiddly, you might get some sticky fingers, but that's okay. There we go. That's my edible Webb telescope. But this is definitely invisible struts. As I was about to say, this is definitely open to interpretation and your creativity. So bring your own ideas into this. Use any bits of things you've got at home, edible or otherwise. Let's see how Kate's doing.
So I'm struggling to currently connect it up, but this is how mine will look in a bit once I've got some more sellotape on it.
Oh no, mine's fallen over. That wouldn't have survived a vibration test, which is how we simulate a rocket launch. There we go. Can stick that back on. There we go. There we go. Those are our little Webb models.
Might give mine a vibration test.
Oh,
vibration test. Oh,
Vicky's is quite impressive.
Oh no.
Hey.
Prime mirror's fallen off. Oh dear.
Right, here's my model.
Oh, very impressive.
There we go, there's my mirror. Very simple.
Are you going to attempt a secondary mirror?
I probably will add a secondary mirror, although I have run out of recycling at the moment. Later on, I can add to it. And I also can decorate it, make it the right. Louise's look like it's broken off.
Oh yeah, I was making my secondary mirror. There we go. This is my little secondary mirror.
So the best bit of things breaking off is that you can eat them.
Yep. I can eat my spare primary mirror as well.
Watching Louise and Vicky is making me very peckish.
I did have to check there were good primary mirrors before we started. I did have one.
Quality testing, very important.
Yes.
Great, thank you all for helping us make our James Webb Telescope. They look absolutely amazing, and make sure you definitely have a go at home. You may want to join in as we go or afterwards. One last question I'm going to end with is, what advice do you have for someone who would like to follow a similar career path to you? Or let's start with Catherine.
To me, it's check that it's something you're interested in. So when I was at school and university, I went on a variety of different courses over the summer holidays. And there I got to meet lots of people who are interested in the space industry and also find out if it was something that I was interested in, so that then I could decide whether I wanted to put all my effort into being a spacecraft thermal engineer, or if actually there was something else that was more suited to me.
Very good. And Louise?
I'd say, yeah, similar. Make sure you kind of have a look at what's out there. Because there are so many different opportunities to work in the space industry or in other STEM industries. And I guess also important that studying is really important, but so are the other skills you can learn from other things. Like extracurricular activities, give you skills like communication and teamwork and that kind of thing are all really, really important too.
Great, fantastic advice. And finally, Vicky, a question for you. When should we look out for the James Webb Telescope? When is it expected to be launched?
We're hoping to see it launch in autumn or winter time towards the end of this year.
Great, so let's keep an eye on the news and hopefully we'll be able to see it being launched. Brilliant. Thank you all, and we will all see you very soon. Bye.